All right, so you're doing these test practice problems. Okay, let's check your work. Did you just recall or have at your fingertips that 5A was our tangent and B was our sine? If not, then you should study those. How about 11? Showing appropriate work. I have 1 over the square root of 2e to the x quantity squared minus 1. Do you agree with that, or shall we go over the work for that?
Please.
Okay.
No, I do not agree with that.
You do not agree with that. I might have made a mistake, but I don't think so.
No, I don't agree because I got violently wrong.
Violently wrong? Okay.
I agree.
All right. You agree with mine?
Yeah. Once.
Right.
It was this question to start with. Is that, or was it 2e to the x? I can't remember. Was it 2e to the x? Okay. Here we go. So you get 2e to the x. What's the first thing we do? You rewrite it in terms of secant. Now that makes an implicit equation where y is implied, but at least it makes it so we can take the derivative of. Now we differentiate with respect to x. What's the derivative of secant y with respect to x? Secant y tangent y, and then by implicit differentiation, dy dx, right? When you take the derivative of something with y mixed up, you take the derivative of the function, times the derivative of the inside by chain rule, and that's why you get that dy dx. On the right-hand side, the derivative is still 2e to the x. All right, so we rearrange, take the implicit derivative. Now what do? Brian, what do?
Well, you divide.
Okay, you divide stuff over to isolate dy dx. That is, after all, the goal. Secant y, tangent y. And then what's the last step? We substitute in for those y trig expressions, usually by drawing a triangle. Now, I don't really need the triangle for secant y because secant y has been defined. Secant y is 2e to the x. Okay. The idea is we're trying to put this derivative in x terms rather than y terms, right? Now, when you put in 2 to the x, e to the x, that's delightful because that then divides away. That's why you don't see that in my final answer outside the root. However, to replace tangent of y, it's a little more complicated. I had some people in the 7th period asking, well, I don't know where I draw the triangle from. There's trig all over.
Oh, I figured it out.
Yeah, that's where you draw the triangle from. Okay. Anybody else? Shall I continue, or are we good? Okay. All right, then. 18, I believe I went over here next. 18. Did you state the extreme value theorem? You might not think that's important, judging by some of your homework. That's my first point on my homework, on my test. States the extreme value theorem. It's absolute extreme at endpoint or critical number. That's important to me. That is what I model. That is what I put points in for. Okay? So, states the extreme value theorem, identifies candidates. First of all, candidates are the endpoints 0 and 5, and then the critical points or critical numbers are where some of the work begins. I distributed the function and found the derivative. The first thing I'd check, or the next thing I'd check is the derivative. Did you get the derivative correct? 3x squared minus 14x plus 10. Did you show, this seems like it's so subtle. Did you show the derivative equal to 0? Or set the derivative equal to 0 / technically undefined, but this is a polynomial, so there's no undefined. You have that shown. That's AP grading. You not only take the derivative, but show it's being set equal to 0. I have rather ugly solutions of 7/3 plus or minus root 19/3 for my critical points. That means I have 1, 2, 3, 4 candidates. I then find what is the y value at all those possible places the y could be at its greatest or least. F at 0 is 0, F at 5 is 0, those are nice and clean. I stored these. In terms of putting these in your calculator, you might consider calculating them, then storing them to A or B, then putting them into your calculator. At any rate, Once you find all the y values, make sure you answer the question. Question could say, find the x at which the max occurs, or what is the max? Yes?
So, on like your own test, technically speaking, wouldn't your work be marked as points because you need to find f?
Your f is not defined in the problem. Was it called y?
Oh, no, it's f. Well, I'm just saying, like, you didn't write the equation for f.
Oh, it's given. I don't need to identify f. It's given.
Okay.
Yeah. If it said y equal, and I renamed it f, you're right, then that would
Okay.
raise me points, okay? But if f has been identified, then you're wrong. Okay? I'm glad you said. Now, they said, I think in the question, what is the maximum and minimum value of the function, which is to say the y value. So these should be your answers. The maximum value is 4.0606 or 4.601061. And the minimum is negative 8.20. How we do? I'll assume that's great. Okay, moving on to 20. I didn't number this. What number is this one?
That's 22 replacement.
This is 22's replacement. Technically, it had an A and a B, but only X areas will be on the test tomorrow. So I am just showing A. Don't forget to go back and find B. But the problem in the line should be at 02. Did you find an intersection point? I don't give points for the graph, but gosh, it's just good to have if you can get it. But the intersection points are the first thing I would check for, 0 and 2. The second thing is the integral. In order to get positive area, you set up upper minus lower. So is your integral 2x minus x squared. Okay? And then finally, your antiderivative evaluated. Your area should be positive. 4/3 is your answer. Cool. 21. People, especially when they're just starting out, think, well, it's calculator, I don't have to show any work. Well, yeah, you do have to show work. This is what I expect to see. I expect for you to report the intersection points to 3 decimals or more. Although you're really storing them, so your final answer is accurate, but those should be reported to 3. It's not just your final answer that you get 3 decimal places. It's everything they look for has to have 3. This should be correct. It's g minus f, which is the log curve minus the e curve. You do not have to write all that out. You can, if they've been named in function notation, use the names g and f. And then your answer accurate to 3. 20, I put the wrong one on top, so that would be bad. But did you get 20.759? I'll assume that's a yes. And did you get, for number 20, A is 10 and B is -5. All right then. Any last minute questions before we move on? Okay, I'll be happy to help you prepare in 7th hour or tomorrow before school. If you have anything you need to practice or you're worried about, I'll help you. Just come in for help. Okay, a little bit of 7th period time will go a little bit. The lesson should be quick. The green sheets, are you ready?
Yes.
Perfect. This should take about 10 minutes, I hope. Mostly it's just what work I expect to see. Even and odd is a characteristic of some functions, kind of like red hair or whatever. Not everybody has it, but some people do, and it definitely makes you unique if you have it. Even and odd, same thing. Not everything has it, but if you, as a function, have even or odd, then it makes you special. Give me some examples of even. X squared. What else? X to the 4th, true that. X to the 0, well, constant. X to the 6th, cosine of x. Would you also consider anything there you're taking the absolute value of x? So that would mean the natural log of the absolute value of x. Or anything such where you put the absolute value of x on, then you're going to get positive x's and negative x's behaving exactly the same. The graphs will have symmetry at the y-axis. So x squared, for example, is supposed to have symmetry at the y-axis. Natural log with absolute value allows you to put in negatives, and the negatives are reflections of the positive, for example. So that's natural log of the absolute value of x. We do that so we can use negatives. All right. Now, the big idea, the definition of even, is f of x is even if f of negative x, when you put in a negative x, you get the exact same thing as if you put in a positive x. The same y value occurs for negative values and positive values. And later on we'll get to integral shortcuts, but might as well get them in now. What's an integral shortcut that even would allow you to use? Imagine area under x squared plus 4. Yeah, there's really symmetry to the area. And that would allow you to use a little bit of a shortcut. Sometimes you could say, if you had an integral from negative b to b, it's equivalent to 2 times the integral from 0 to b. That's kind of handy because 0 is so nice to work with. That would save us some time. All right? Odd. X cubed, sine of x, tangent of x, etc. Symmetry is at, or about, or through the origin. Students typically, or at least in pre-algebra, struggle with point symmetry. What does it mean to be symmetric about a point? It's not the same as linear symmetry or axis symmetry. Okay? Point symmetry is if you draw through that point, then what happens on both sides is the same. So no matter where I draw, I first of all hit the curve in the same way, and the distance would be the same on either side. No matter where I draw. So this distance and this distance would be the same. This distance and this distance would be the same. So point symmetry is such that when you draw through it, same thing happens on either side. That would mean then that when you put in a negative, if you change the sign of x, then you change the sign of y as an outcome. Okay. Notice I didn't say you could pull the negative out front, which is total nonsense. That's not what I said, and it's total garbage. It's behavior on the negative x side is going to give you the opposite y value as on the positive side. The integral shortcut is delightful, as that picture kind of indicates. If you did symmetry about the origin from negative b to b, you'll get some negative area, some positive area that are totally equal, and therefore they will cancel out. And any integral done in a symmetric way about the origin will come out to be 0. All right, then. This is what your homework problems will look like. Show a function is even, odd, or neither. Neither. Please, would you make sure you understand the difference between show and state? It doesn't say if it's even or odd. It says show it is even or odd. You prove it is a proof. Okay? You are in all cases putting in a negative x. For example, f of negative x, and you're simplifying to see if f of x, negative x, comes out the same as f of positive x, in which case you conclude even. Or f of negative x is the opposite of normal f of x, which you conclude odd. Or f of negative x is neither of those, which is then neither. This is what I want to see. If I ask, is this even or odd or neither, the first thing I'm going to do is say, what happens if I put in a negative x? What is this doing on the left side? You do the same on the right side then. Put in a negative x, and we simplify the right side to see, is that same as f, opposite of f? What is negative x quantity squared? x squared. What's sine of negative x? Negative sine of x. Altogether then, if I were to clean this up, I could move that negative out front, and all then I would have is the opposite of x sine of x. Well, x sine of x squared sine of x is f of x. So it seems like when I put in a negative x, I get the opposite of f of x, and that is the definition of odd. Okay? Try the next one on your own. Oops, not F, G. Conclusion? Odd. It is also odd. Okay. Jump to K, please. Jump to the last one. K of x is in the far right side. Doo-doo-doo. What do you get? K of negative x equals K of x, and therefore we conclude even. All right, try the middle one now, or that third one. So when you put in a negative, there's not much to do with the exponential, right? It's just kind of stuck there. I guess you could call it e to the negative 2x, but we can't put it out front and call it the opposite of the first term. It's not the same as the first term. So what do you conclude? Neither. As far as what I'd like you to say, something like this is not h of x, so it's not even. This is not negative h of x, so it's not odd. And we conclude okay, that should get you going. Do you want to try 3 or 4 up the homework, or go to homework questions? Do you have a lot of homework questions? All right, set 67. What do you got on the homework question? 25. 1. 25, 1. What'd you say? 10?
10.
10.
8. Oh, we're not getting. 10 on the back. Was that supposed to be 17?
10 on
This
the.
is 10 top over there.
Oh, yeah.
Is that supposed to be 17? That's just.
Is that where the number should have fallen was 17?
I suppose.
Yeah.
Oh, I just think so.
That's an important one. 17, yes. Change.
Okay.
10 on the back was supposed to be 17.
That's what.
Sorry about that. Those, we might want to go over. Those are rough. Okay, 25. 25 is a humdinger. Ran out of time in the last class, so I'm anxious to see how this goes. All right, so they tell you f of x equals x cubed minus x squared minus 4x plus 4, ab is on F and a tangent line is drawn there. And they say the tangent line also passes through 0, -8. What are A and B? So, what did you do to start with? Did you get started? That's one thing I can do. You can graph it, that's true. Okay, so let's go with the derivative. The derivative is 3x squared minus 2x minus 4, and at A is 3a squared minus 2a minus 4. Okay, I agree. I mean, that seems like good stuff. What else do we do? Okay. Okay, let's use A, B to the max here. First of all, anytime they give you a point on the curve, you should use it in the simplest possible fashion, which is to say, when you put A in, you get out B. That right there is the relationship between A and B, because A and B is on the curve. I know that. Yeah? I like the derivative, especially towards working with that in conjunction with the point to get a tangent line. It seems like if I put those two facts together, then I get a tangent line of y minus b equals 3a squared minus 2a minus 4 times x minus a for my tangent line, yeah? Are you with me? All right, now, big idea of calculus, or actually math in general, is if I have two unknowns, I need two facts that relate those two variables. Here's one. The point is a relationship between A and B. This is close, but it has x and y in it, so it's not quite an A-B relationship. So where do I go from here? What have you not used yet? I mean, I don't usually give you stuff for random reasons. What haven't you used it? Yeah, that's 0, -8. Is that a point on the function or on the tangent line? That's on the tangent line. So if I use that tangent line point, then I get something like -8 minus b equals 3a squared minus 2a minus 4 times 0 minus a. That feels like another relationship. -8 minus b equals -3a cubed plus 2a plus 4a. Is that enough to get us going, you think? Substitute or eliminate? Let's go with substitute. If I throw this in there, then I get -8 minus a cubed minus a squared minus 4a plus 4 equals -3a squared plus 2a. Should this have been 2a squared? 2a squared plus 4a cubed plus 2a squared plus 4a. Okay, so -8 minus a cubed plus a squared plus 4a minus 4 equals -3a cubed plus 2a squared plus 4a. Everything on one side, I get, let's see, what's the best side to go with? Let's go everything on the left side. When I add -3a cubed over, I get 2a cubed. A squared, when I subtract 2a squared over, I get -a squared. 4a minus 4a, that's gone. And then that -8 minus 4 is -12. Do you agree with that? I don't like that at all. Well, surely they don't want me to solve a cube, do they? I guess I could. What does that do for me though?
Nothing, so don't do that if that was going
I
on.
mean, you can find a squared plus or minus a squared, well, or a. Go for that.
Does moving the 12 over do me any good? In other words, mostly, I guess, big idea of math. Does factoring do you any good when there's anything but a zero on the other side? Yeah. So, I guess cubic solving time? I hope I did my algebra right, because I don't want to solve cubes for no reason, darn it. 2, -1, 0, -12. Possible answers are 1, 2, 3, 4, 6, 12 over 1, 2. Doesn't feel like 1 would work, do you agree? Or -1. How about 2? 2, 4, 3, 6, 6, 12. Bingo. Boom. A minus 2 taken out yields 2a squared plus 3a plus 6 equals 0. Wait. Guess we could have used our graphing calculator to find the roots, huh? Just occurred to me. Oh well. By quadratic formula, then a is also -3 plus or minus 9 minus 4 to 6 over 4. Is that clean? That's imaginary, yeah? Okay, so it seems like only a equals 2 is a real solution. And if a equals 2, then b equals a cubed minus a squared minus 4a plus 4. 2 cubed minus, what did I say? 2 squared minus 4, 2 plus 4. 0? Super.
That was awful.
Yeah, no, that was quite challenging and fun. Okay, I'm down. Sounds good. I'm cool. Okay, question on 1. Is number 1 a question for me? All right. Just 35 years All right, so here's the flag pole. The flag is raising. And here's Gaurav. The angle is drawn from his feet. Okay. He's standing 5 meters away. That does not change. That is constant. Leave it 5. The flag is being raised, so this is varying. I'll call it y. Find the rate of change in the angle of elevation. So they want d theta dt, given that the flag is being raised, dy dt is, or y is changing at a rate of 1 meter per second. At the instant when y is 12 meters. Okay, so what's the trig relationship you use between the variables theta, y, and phi? Sine, cosine, tangent, Pythagorean theorem? Tangent it is. Tangent of theta equals opposite y over adjacent 5. Differentiate with respect to time. Secant squared theta d theta dt equals 1/5 dy dt. Solve for d theta dt.
Good morning. Please rise for the Pledge of Allegiance. Ready? Begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Are you on pins and needles? Stuck on your holiday shopping? Make sure you're hopping to the book sale on the 13th to shop for the readers on your list.
Do you want to serve on a focus group to have input on the hiring of our new principal? Stop by the library in Mountain Corner now by this Friday if you're interested.
Is 10 then, is this 10 the 10 on the front or the back?
Exploration series
Whoever asked.
are leading the world into the future. Join us today in the library commons area during your
Tens,
lunch
whoever
program
asked.
about the exciting future of software engineering and computer science.
Oh, whoever asked 10, which one do you want? First. The real
We
10?
invite you to the fourth annual Future Teaching Conference on February 23rd, 2018. This free program is for students interested in teaching. Deadline to register is January 27th. Counseling has the details.
Hey Jack, consider participating in Cause for a Cause, the Dublin Giving Tree gift drive. There's a tree in the front office. Each of the ornaments on the tree has a gift or aid on the front as well as instructions on the back. Feel free to take an ornament or two and then bring back your tag with the unwrapped gift before December 16th. This is a great opportunity for Dublin students to share their families and friends in our community.
It's time for the 24th annual Holiday Brouhaha and Cross Show this Friday, December 8th. 2 shows featuring men, all new and proper Randall with a straight to Cross Show immediately after school and a competitive and Cross Show at 7. As always, all you need is a $3 donation to attend.
Want to help us out with our pool rental?
Okay.
We'd love for you to stop by the girls' swim and dive team, Chipotle fundraiser tomorrow from 4 to 8 p.m. to the Southwest Plaza Food Court. Please mention Devlin.
Yeah, it's Sunset Tiger and help the boys basketball team. Mark your calendars for Wednesday, December 13th for Sunset Tiger at all 3 locations all day. Mention Devlin Rocks at the time of your purchase, and 100% of your purchase will be donated to your Devlin boys basketball team.
There will be a parent interest meeting for the summer Mexico trip in the library tonight from 7 to 8 p.m. Stevens and Stevenson, if you are interested but cannot attend.
Yeah, that's rough. Okay, so seems like everybody's lower the 0 minus her.
Please request prior to next Thursday, December 14th.
Aslan Jags, the junior high school scholars of the month for December
Curtis
was
Glue the
selected by the
Axis.
math department and are as follows.
Joanne Wing, nominated by Mr. Slaughter, has been a wonderful student all semester and has worked hard to constantly be her best. She has a great attitude every day and comes to class prepared and focused. I am extremely proud of her work ethic and intelligence.
Kate Miller,
There's
nominated
your
by
intake
Mr. Block, is a gifted math student in Algebra Geometry 1 as a 7th grader.
Yeah, jump on.
Besides his natural ability, he has a strong work ethic and is a valuable member of the classroom. He has enjoyed math competitions and is the only 7th grader to qualify for the second round of the very difficult University of Northern Colorado math competition. Congratulations to all our scholars of the month.
Saw your announcements, Jack. Have a great day.
I get something like pi minus 2. That was a toughie, all right? Okay. Any other questions? 3? Okay. In terms of the trapezoid formula, one of the sources of error in the last class was B1. Is B1 2 x's? Just straight up 2. Okay, no matter how you draw, that lower base is always 2. So let your area be 2 plus 2x's times y over 2, which could be, I suppose, cleaned up to 1 plus x. And then y is the square root of 1 minus x squared if x squared plus y squared equals 1 is solved for. After that, it's derivative time, finding a prime positive to negative. Yeah. So I'd say something like 1 plus x times negative x plus plus x squared. Yes, I'll take this at the end of the day tomorrow, because we don't have any homework due tomorrow. I'll take it tomorrow. Sure. Oops. Guess I could have taken out 1 plus x from both sides, huh? I think it would have been better to call this 1 plus x, 1 minus x, so I could take out 1 plus x. There you go. Boom. -1, which is a critical number, not a critical number, and x equals 1. Boom. Hi.
Mr. Rick,
Yeah.
any of those like word problem, like similar to the lake one where you're finding the population
Oh.
to be around the lake? Will
Yeah.
that be on the test tomorrow?
It is not. I didn't feel like I practiced it. We
Okay.
practiced it, yeah. No.
I know I had it 20, and all of a sudden, I didn't have the 20, and I thought, I wonder if I paid money.
Thank you.
I have.
I appreciate it.
I don't have the 20 yet. But I had it in my pocket, in the registry. Like that day, the very same day you asked before, and I just,
Maybe it's in the laundry.
yeah, my beat, yeah.
Happens to me a lot. Thank you.
I did it after school, right, Darlene?
After school, I'm pretty sure. You bet.